All right, it's live. What's up, peeps? It's Robert Bassano, Planete Veritas. Like I always say, it's not what you know, it's what you can prove. So we are bringing you a little bit more proof today. We got What's up, peeps? We got Hank Hill, we got Mark Diesel, we got Robert Shortman, man, Mr. Antarctica, the new Shackle, the new Admiral Byrd of the 21st century. And we got Johnny, my boy John. What we're going to be talking about today is more evidence of spherical insanity. Kansas is where? So Hank's going to explain that. Focus of today's discussion is what we are sticking to as two pieces of solid information, documented information, to prove we do not live on a spinning damn basketball. Okay? There's no curvature on a flat plane surface. All right? Maybe there's some curvature on the outer layers of the atmospheres, hundreds of miles above us. All right? But where we live, work, travel, walk, do all our other business, it's a flat plane. So I'm going to let Hank take it away. He's got some information to share with everybody out there that we had took a look at and talked about that is pretty incredible. It may even make a few of you laugh when he presents this information. And then we're all going to readdress the Railgun technical capabilities and what it can do. And then from there, it'll be a free-for-all. We'll talk about some other things. So, Hank Hill, the floor is yours, my friend.
All right, thanks, guys, very much for having me on here. I appreciate it. Get a little feedback, though. Yeah, not anymore. All right, so from coast to coast in the United States, from the west coast to the east coast, is roughly 2,800 miles. And the tangent point in the middle is Kansas. So let's say 1,400 miles. 1,400 miles times 1,400 miles times 8 divided by 12 is not 2,000 feet above sea level. So it's 1.3 million feet. And Kansas is, on average, 2,000 feet above sea level. So we're talking about an arc from point A to point B, from west coast to east coast. Kansas being roughly in the middle, we should see an arc of 1.3 million feet above sea level if it is a ball indeed, which I'm saying that it's not. And we only see 2,000 feet above sea level on average. Now, I'm not saying it's perfectly flat. There's hills and valleys and everything else in between. But from point A to point B, you're walking up 2,000 feet and you're walking back down 2,000 feet. That seems like a gentle slope instead of a ball that is a sphere that is 25,000 miles. So basically, where's the arc? Where's the curvature? And this is not math that does not relate to reality. This is math that absolutely directly relates to reality. So the problem is, if Kansas is only 2,000 feet above sea level, that's not very much at all. And you can do the same with Montana. It is also, on average, 2,000 feet above sea level. So we're talking about walking up and down a hill. We're not talking about walking across a ball. And you can do this same thing with Africa, any other continent you want to do it to, and you'll see that if you do it in Africa, it's only 1,500 feet above sea level in Central Africa, and the number for that one is way bigger than 1.3 million. So there is problems with people telling us that we live on a ball. It appears, well, it's obvious we live on a flat plane, and that's why they call it sea level, which I'm measuring from. That's why they call it the plains of Africa. We live on a flat plane, folks. So that's all I got for now. Go ahead, guys.
Okay, great show. You guys have a nice day, and thanks for watching. No, seriously. So what I want to try to do is pull up the map here real quick. Who was taking up a lot of bandwidth. So,
Hey, Robert, you're breaking up again, man.
you guys any better? Mark, man, really, what the hell's going on back there, bro?
What'd you say?
What's going on back there? You okay?
Yeah, I'm okay. What?
Okay, so what's all the rust, bro? Who are you fighting with?
Oh, I was walking down the steps. I'm sorry. I thought I had my mute on.
All right, so I'm gonna show this illustration on Google Maps to get everybody orientated to what Hank is talking about. Let me do a share screen here real quick. Yeah, you might want to mute Mark. And what we'll do, take you guys to Kansas. Now you saying, Mark, I mean, Hank, you're saying, where'd you measure the distance from?
East Coast to West Coast, just roughly 2,800 miles, and the tangent point in the middle is roughly Kansas.
Where'd you start on the West Coast?
Anywhere LAX is fine with me. You can start
LA?
LAX. Yeah, you can start there and just walk right across. It's roughly 2,800 miles. And I rounded it up. It's not exact math, but you get the picture. It's close enough for everyone here to get the picture.
Okay. So let me zoom out. So this is what we're going to do. We're going to get directions. So you're saying from like LA to Kansas, it's around, what, how many miles you say?
About 1,400 miles.
Kansas City?
And in 1996, these scientists got together and they surveyed Kansas and came out and said that Kansas is literally flatter than a pancake. So, yeah, that just adds to it. This is second confirmation.
Well, from LAX to Kansas is, according to Google.
That's not Kansas. That's Kansas City, Missouri. Go to Kansas. Go to Topeka or something.
Yeah. You guys speak on that thing. Kansas City, man.
And Robert, I think your microphone's still a little bit choppy.
Yeah, when you muted and came back in yesterday, it was good.
Hey, get Missouri out of there. Yeah, and I think Hank was just going from sea level, from California sea level to New York sea level. So
Yeah, it's just roughly. I mean, it doesn't have to be an exact spot.
right.
I'm measuring from sea level, not from any particular point on the West Coast. And when I measured it across, it's roughly 2,800 miles. And sea level is almost identical on the West Coast and East Coast. Some people argue that it's maybe a couple of feet. Come on. I mean, I don't want to argue about a couple of feet. We're talking about 1.3 million feet as opposed to, on average, 2,000 feet above sea level. So we're measuring from the sea level to get the shape of the Earth.
Okay, so let's just say roughly. I mean, we're a little bit further along, close to the border of Missouri. But let's, for argument's sake, let's say, we're here. It's about 1,500 miles, give or take. And I can actually change this route. wanted to. Let's go to Great Bend. That's like right in the center. 1,358 miles. So give or take, yeah. So 1,358 miles, right? So if we go from Johnson City to New York, right? That's Great Bend. Let's do this. So we'll go from Great Bend to New York. Remember that number, 1,359 miles.
Got it.
Go to New York City. New York City, New York. Let's see the distances on that. So from Great Bend to New York is 1,400 miles. About 1,440 miles. So let's say 1,360 miles plus 1,440 miles. You're looking at 2,000. We're looking at about 2,800 miles. And
So let's just divide it. Sorry. Sorry, I was just going to say, let's just divide it right in the middle, 1,400 and 1,400.
Yeah. So let's just say, yeah, average 1,400. And Kansas is supposed to be, how? Kansas is supposed to be 2,000 feet above sea level?
On average. There is high spots and low spots, but on average, it's 2,000 feet above sea level.
Sea level elevation of Kansas. Okay. Let's go to this one here. This gives you Fact Monster. Fact Monster is the highest, lowest, and mean elevations in the United States. So Kansas, 2,000. There you go. Exactly what he said. 2,000 feet above sea level. So, John, are we going back to Metabunk to put this number in? Wait. They're saying the elevation here. If Kansas is 2,000, they're saying the elevation.
Robert, your microphone's still messed up. I'm sorry, sir.
They're saying the lowest point is 2,000. The highest point is 4,000. No, I'm sorry. Elevation 2,000. The highest point of elevation in Kansas is some damn mountain or hill, another 2,000 feet. But the average is 2,000. Okay. So let's go to Metabunk.
So.
Okay.
Okay.
And if we put in, I don't know why John likes to use this. Is this a proper site, John? Dude, he disappeared.
Hold on a second. I'll send you the link.
I like using that other one you gave me.
Right. It takes you right to it. 1 second.
I got it pulled up right here. What number do you want to put there?
I'll just give it to him.
Okay.
There you go, Robert.
Okay. So distance is 2,800 miles average. Your height in feet was 2,000 feet, right?
Now, you would have to do, what would you have to do there? 2,800 miles, you're going the whole way across. You would have to go, you're looking for the curvature. So that, I don't know, just put 1 foot.
You want to put 1,400 because you're looking for the middle. You want to see how high the middle should be. So
okay,
it's
2,000 feet, right?
on average, yeah, 2,000 feet above sea level on average.
So there you go, right there. The horizon should be at 54.77 miles. The hidden amount, holy shit. You got, goddamn. You got 1 million fucking feet of landmass you shouldn't be able to see. And the bulge height is 329,334 feet. That's supposed to be on a ball. That's impossible. You're saying the horizon distance is 54 miles. So if we go back to the map, if I go to ground level, let me go to Great Bend. Let me go to Great Bend. Let's see if I can get a street view here. Oh shit. Yeah, this ain't going to do this way.
So I understand that there is different math that you can use, but I'm just doing this for myself and for the layman like myself. So the equation that I used was half of the distance, which is 1,400 miles, times 1,400 miles times 8 for inches divided by 12 for feet. And I came up with 1.3 million feet for the curvature that we should see.
Wait. So you multiplied?
Yeah, it's square the mile, right? Is that right? You're supposed to square the mile, 14 times 1,400?
No, you can't square the distance off because then you end up with double the result. You don't square it off. You don't square it off.
All right, well, thank you for correcting me. I do apologize.
You don't square it off.
I just heard something from Hillbilly, because he knows a little bit about the mean sea elevation, and he said when you search for the elevation of your hometown, the mean sea level is 0 number of the elevation of that elevation.
Yeah, but even without squaring things off with the number that Hank just gave, you don't.
It's still yeah, you're right. It
Yeah,
still
because wait. Did it print this out like this? Did it do it like this? Hang on a second. Just do this again. Hang on. Let me see something. Because the distances you're given, Hank, what you're doing is measuring the size of the U.S. from coast to coast, the continent itself. And I guess this is where you're supposed to be. You can't move this damn thing. This is where Kansas is supposed to be. Okay, Great Bend at 2,000 feet above sea level, right? And you should only be able to see 54 miles. And that the rest, they're claiming that the rest of that million plus miles is hidden. Which means that if you kept on this straight linear path, you got 1,000,000 miles of this. This is your 1,000,000 miles right here.
Hey, Robert.
This line being drawn across right. Actually, no, I'm sorry. My mistake. Here's your 1,000,000 miles right here. Here's the line. They already give it to you. Here's the bulge where it starts. So they're saying you should only be able to see 54 miles. Anybody living in that part of the United States think they can see more than 54 miles?
Hey, Robert.
Yeah.
Hey, go back up there. Let's see if this makes a little bit more sense, because you got viewer height. Go ahead and put 2,800 miles in distance. We're going to take, no, the other one. Distance in miles. Go ahead and put 2,800 in there. And then see the view. No, wait a second. The viewer height in feet. Go ahead and put 1 foot. We're going to say 1 foot above sea level, looking 2,800 miles away. Now, look at that number. This is saying that from the sea level in California looking to New York, just pretend we can see New York.
Mm-hmm.
This is the midpoint of that is what Hank's saying should be Kansas. Is that correct, Hank?
Yeah.
Yes, sir.
Okay, then scroll down. Go ahead, look at that graphic. See right where that bulge height is? That's where Kansas should be.
Right here.
Now, go to the middle point of the bulge height.
This one.
Yeah, that should be Kansas right there. So that distance above sea level, you just had the feet. I think that's correct. That the bulge height right there.
Yeah, but see,
See, it's 1.3 million, right? Is that
oh,
what it
no,
says?
it's 1.22 miles to the horizon.
Yeah, but we're not worried about the horizon. We're worried about the bulge height.
Yeah.
That's where Hank got his number from, the 1.3, Hank, is that correct?
Yes, sir. The 1.3
Yeah, that's
million is the result of 1,400 times 1,400 times 8 divided by 12. And that was the ball Earth math that we've been using for a while. If there's something better, please let me know.
No, there's nothing better. He's got the same thing right here, man. He gives you all the calculations right there. It's spot on.
This hitting amount for me, I mean, you got almost 4.7 million feet. This was what we had talked about with Hank the other day. You got about 4.7 million feet of hidden terrain you can't see.
That's right. But Hank's saying that Kansas elevation should be 1.3 million feet high.
Yeah, exactly. On the ball, meaning that Kansas. Let me pull this shit up here. Kansas should be, taller than Mount Everest.
And this is anywhere in the world, any continent, you can do the same formula, find out the distance from coast to coast, measure it from sea level, and you'll see that it's nowhere near what it should be if we were on a ball. And Hillbilly taught me to measure from sea level, so I got to give credit to him. And this is the best evidence I've seen for a flat Earth. Definitely the best.
So if you take the way the United States is measured 2,800 miles coast to coast, and Kansas is the center point. That means that Kansas on a ball would be over 1 million feet above sea level. It would be the highest point in the United States.
Well, Robert, didn't they have a study out that said Kansas is like flatter than a pancake or something like that?
That's what you're saying. That's exactly what it is.
How can you have a geometrically flat plane on a sphere or a ball?
So I'm looking for arc here. There should be arc between point A and point B, and what I'm seeing is a gentle slope, incline, and then a decline. We're trying to measure the arc of the continent, and there is very little arc, 2,000 feet on average.
Yeah, exactly.
Yeah, this is interesting.
And you don't even have to do this. I mean, this was a great presentation, but all you'd have to take a look is just Kansas by itself.
That's it.
It's a geometrically flat plane on a sphere. That's a contradiction. You can't have that on a ball.
Or Central Africa. It's even lower.
Wait, are they saying the whole state is that way? Because at the highest point that we just saw is about 4,000 feet above sea level.
Yeah, I don't have that study on me. I didn't store that anywhere, but I've seen it. I mean, that's legitimate.
Yeah, basically what it was is I could be off by a little bit, but the study showed that Pancake's value was at 1, Kansas was at 0.93 or something like that. It's literally flatter than Pancake.
Yeah, they're saying Mount Sunflower is the highest point in Kansas. That's the highest point. It's about almost 2,000. It's almost double.
Is it okay if I log in on my computer and screen share what you're talking about, guys?
Yeah, absolutely, absolutely.
Well, this is basically like what people have been doing with their cameras and stuff like that, zooming into stuff that you shouldn't be able to see because it's supposed to be over the horizon.
Yeah, let me do the screen share for Hank. Hank, you want to go ahead and do screen share?
I put into that.
Yeah, give me just a second.
I put into that Earth curve there. You go a distance of 50 miles, and there's a viewer height, which you can just translate that back to a building being 100 feet high. After 12 1/4 miles, you shouldn't be able to see the top of that building anymore.
Yeah, you're right.
But we
Hank is already presented him, so I'm doing screen share. You can go ahead and when you're ready, Hank. Is
All
that
right.
him?
All right. Kansas is flatter than a pancake. This report, we apply basic scientific techniques to answer the question, is Kansas flatter than a pancake? So what they did is they measured a pancake from the International House of Pancakes, and they measured Kansas. And the result is, let's see, conclusion. Simply put, our result shows that Kansas is considerably flatter than a pancake. Mathematically, the value of 1.0 would indicate perfect platonic flatness. To calculate the flatness of the pancake, transect from the digital image is approximately 0.957, which is pretty flat but far from perfectly flat. So what they're saying is that Kansas flatness is approximately 0.9997. So it doesn't get flatter than that, I mean, unless you're talking about just a perfectly flat object. If 1.0 is perfectly flat, 0.9997 is pretty damn close.
Yeah.
How far is that? What's the distance from point to point then on that?
I'm not sure. Let me see if I can find it.
How big would Kansas be? That's probably the best question. I'm not sure myself. Must be some size.
Yeah, this is interesting, man. I mean, all this data we're coming up with, man, is out in plain sight. I don't understand how something like this didn't come up before. Especially with using Kansas as a frame of reference. I mean, 2,000 feet above sea level, you're talking about a ball. Then that means Kansas is the highest point in the United States. If you go, I mean, if you're taking just, I mean, if you're just measuring that landmass alone, just the United States coast to coast. Hillbilly wants to come in and talk about this.
Yes, yeah, I'd like to. He's got some good points on the mean sea level and other things.
Oh, yeah.
I can pop him a link. He won't be any trouble at all.
Yeah, tell him, no, I don't want it out there in the open.
Yep.
He can send me an email. I'll send it to him in email.
Okay.
Hey, John, remember we were talking about testing things using the scientific method?
Yes.
This is one of those things. We take a given building, a certain height, and we should only be able to, that top of that building should disappear after X amount of miles if there's a curve. Given a curvature, the top of that building should disappear over the horizon past X amount of miles. And if you go past X amount of miles and you can see the top of that building, there's no damn curve.
Yeah, that's true, but that leaves you open to, you ready for the canard?
Go ahead.
Refraction, illusion, mirages, but we're going to solve that problem here in a couple minutes.
But all that's just conjecture. You can't prove that that's what's happening.
That's correct.
So if people want to come out with opinions, conjecture, and supposition, then that's complete bullshit.
Yeah, well, we're going to solve that problem here in a couple minutes. Hank already just did. We're just going to pile on here in a couple minutes.
All right.
So what this does is this takes empirical science that anybody can test and retest, and this kind of does away with all that refraction and guesswork and all that stuff that people like to claim. This shows that for a fact that we're on a flat plane.
Oh, but it's just Kansas.
No, the rest of the United States is also pretty close to 2,000 feet on average. Yeah, I'm not talking the whole thing is perfectly flat. I'm just saying that there's a million feet of curvature missing in Kansas and everywhere else in the center of the United States or in the center of any continent.
Right. I'm gonna pull up a map because I've got a place that's I'm gonna look at where it is in relationship to the coast and Kansas, but I think it's about halfway. And the mean elevation around there is about 1,000 feet. I'm zooming out. I'm checking the map. Yeah, sure shit. It's almost dead center in the middle. So if you go from the east coast of the United States to Kansas, halfway in between, the mean elevation around there in most of the places is about 1,000 feet above sea level. You know what I'm saying?
Yes, sir. And when I did it for Africa, it was 5,000 miles. So I did 2,500 times 2,500, and that number was 600 million, I think. Let me double check that real fast. Okay, it looks like I was wrong. 41 million. So Central Africa is on average 1,500 feet above sea level, and that's where you get the plains of Africa. Africa is literally a giant plain. And I don't think anybody can argue this point. I mean, what are they going to do to argue this point? We're using math. That relates to reality. This is not theory. This is something that anyone can do and check and verify.
I think they're probably going to say something about how terrain changes and things like that. You know?
Yeah, man. We in here. Claim your inheritance. Slow. It's a flathead, bald head debate.
Who's on here?
I don't know. Ask Robert. There's a couple of people just jumped in.
Claim
I
your
just
inheritance.
jumped in, but I was given the link through email.
Okay. Oh, that's Political Hillbilly just joined in another
My name isn't popping up.
Political Hillbilly. Yeah, I got you.
Yeah, I know what that is. That's Devon. Devon's got his channel, Claim Your Inheritance. He talks about some of the ancient bloodline heritage and history. You got an interesting channel. I'll share it with everybody. Yeah, Hillbilly, go ahead, man. I'm going to mute if everybody else will let these guys get. I want to hear what they have to say.
Here, can I do a screen share then too? Sea level was explained wrong here. Even on the heliocentric model, the argument that was presented ain't a very good argument. And I'm going to go ahead and cover that. Not to be taken away from Hank's point, because Kansas is definitely flat, but so is sea level. Let's see. So,
right. Well, listen, whatever you do,
this is all I'm going to show.
Hey, hang on. Don't show anything that can be copyrighted. It's $100 per incident.
No, this is mine. This is mine. All right.
All right, go ahead.
Okay. Now, sea level is the on a heliocentric model would represent a true 360-degree circumference with uniformity. Uniformity is always the key when you're looking for measurements of sea level. Now, let's say that this example here, I got it set up for 1 mile, but let's say that it was coast to coast of the whole entire United States, putting Kansas somewhere in the top, right? Now, if we was to use sea level to figure out its measurement, there's why you're reading it's 2,000 feet. So it shouldn't be, I'm getting a bunch of feedback. But so on a globe, it could look that way, but it's when you measuring for sea level. I'm going to go ahead and drop my headset off my ears, see if I can prevent feedback. When you're looking for sea level as the forms of measurement, note the uniformity of it. If we was to reestablish it above the Earth's surface, this is what you would expect to see on the heliocentric model. You would have a control plane knowing that the beginning and the ending of your mile is at the exact same elevation, meaning there's uniformity in this tangent line here, of this tangent line here. Well, all the rest of the tangent lines in between have to be uniformed in length too. So that's what gives you the protrusion or the arc. So when we're doing this, we cannot measure up because we'd be inside of Earth. So we'd have a subtraction plane to measure down. This subtraction plane would be 12 inches above the control plane. So right here at the beginning of the mile, as I measure down, I should be able to measure 12 full inches. Here at the eighth of a mile, I would measure down and I would come up with 11 inches, proving 1 inch up if there was a heliocentric model to do this on. This is the quarter mile. I would get 10 inches down, proving 2 inches up. 3/8 of a mile, I would get 9 inches down, proving 3 inches up. Half mile, I'd get 8 inches down, proving 4 inches up. Going back downhill, it'd go just the opposite. Here I'd get 9, proving 3, 10, proving 2, 11, proving 1, and here I'd get my full 12-inch measurement again. If there was a heliocentric model to reperform this test on, this would be the results. But as you do this by means of sea level, by utilizing the same benchmark for all elevations, you'll find that here it will read 12 inches, here it will read 12 inches, 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 proving, according to mean sea level, we are on a flat plane. A lot of people will put up the argument that there is actually no slope here in the middle of the mile. That's just a perspective argument. That's what you see. Because as we change the location, we're not changing uniformity. So let's go over and look at the second section of the round chart, the heliocentric, where we got more than 1 mile together. Let's count 4 blocks in. 1, 2, 3, 4. There's the same exact curvature that you're seeing right here. So it's nothing more than a perspective issue. Here it looks greater than what you was thinking an inch would be. Here it looks less. But nonetheless, it's all uniform. There's uniform tangent lines, uniform sea level, uniform control plane, uniform subtraction plane. If I was to ask anybody to divide this blue circle here up into three sections evenly, nobody would have a problem saying, just draw a peace sign. I just got my 3. If I said divide it up into quarters, nobody would have a problem saying just draw crosshairs in it and I got my quarters. Or 8ths, or 16ths, or 32nds, or 64s. Not only can I do it that way, I can do it per 100 miles, or per 10 miles, or per 1 mile, or per 8 inches, or per 1 inch. That's exactly what we just did here, per 1 inch. Science will tell you to remove any unnecessary complications when utilizing true science for observation to get repeatable results. The complication in this method is the square. In any one given mile, there is no square, unless somebody can argue that 1 times 1 is anything greater than 1. So let me put the square back into the first mile. 1 times 1 times 8. 8. I still got 8 inches in any given mile by itself. So this is what you would expect to find. Ironically enough, this can be repeated for approximately $200. And when we do it, it reads flat each and every time. This is where I have my $1,000 challenge out. Nobody's yet claimed $1,000. But anyways, I did want to explain it to you. You guys got mean sea level all messed up. This is how it's measured. So if we was on a globe, Kansas could be right here and still get a 2,000 feet reading. like Denver, Colorado will never change. It'll always be 5,280 feet, representing Mile High City. But that's the only reason why I really wanted to jump in, because sea level is being misrepresented real bad.
I
It's funny
apologize.
you
That
say
was not
that.
on purpose.
Go ahead.
It's funny you say that because when I was a bald head, I used to always wonder how in the world is the Nile River flowing north. I never understood that until it
They,
made perfect sense on the flathead model, where lower upper Egypt is a higher elevation than lower Egypt, which lower Egypt is in the north and upper Egypt is in the south.
That's interesting.
yeah.
That is interesting.
Another good example I like using is sanitary sewers. When sanitary sewers go in, they got approximately 6 inches of fall over a mile. They can't be put in with too steep of a fall because the waters will leave the solids and the solids will start collecting in the joints of the pipe. So we have to lay it pretty much flat with just ever so slight downhill. Well, when we do that, if we're only given 6 inches in a mile, but there's 8 inches of curve, by the time we get to the half mile, we got a negative 1 inch of flow, meaning that your solids should be standing in your basement.
And you're so right, because I'm a plumber, I can concur with that fall and drop. You have that on every pipe system, wherever it is, because if you haven't got that slope, either if it's too steep, the solids are left behind and the water overtakes it. If it's too shallow, then you just get it stagnant anyway. So it has to be on this set parameter for it dropping from one end to the other, so it carries the solids and everything away. Sorry, carry on.
Exactly. I never gave that thought. You was a plumber. You would understand.
You know, this got me thinking about something of what the guy from NASA said regarding the expansion and contraction of the atmospheres during the solar cycle. The same exact thing is occurring, you know, on the ground and sea level. The oceans are expanding and contracting. So these numbers that we're coming up with, they're going to, of course, vary just like the atmosphere does. So Kansas could be 2,000 feet above sea level today, and 6 months from now, depending on the atmospheric cycle, Kansas could drop 1,500, 500 feet. Or
No,
rise
mean sea level never changes. It never changes. It's the it's the average between the low and the high tide, removing any acts of nature or any man-made acts in a change of the tide system.
Well,
So what? It's an
you do
average between.
understand. You do understand when they say mean sea level, what they mean. Not, and I don't mean literally mean. Mean sea level means an average between the high and low. That's what it means. It's an average, which
And it's
means that you have
established.
a decrease in where Kansas would be
No,
at a particular time of the year, or whatever the cycle may be.
no.
And what's happening in the oceans and what's happening in the atmosphere. And I want to go back to what I have been initially pushing regarding the equipotential ellipsoid, is that the International Ellipsoid Reference System and the World Geodetic System, they all agree with what you said, what Hank is saying, what we're all saying, but they're also concluding that the Earth is undergoing continual flattening. So 10, 20, 30 years from now, if they decide to do another measurement, a worldwide measurement of certain particular places they're focusing on, because in the International Ellipsoid Reference System, they list specific locations for a reason. And those locations are based on the flattening of that particular location. And Kansas is one of those places they put on the list. And there's places in India, there's places in China, there's places in Africa, there's places in Latin America. But they put these places on the list, and their degree of flattening varies to about maybe one, 1 to 1/10 of a foot in flattening, meaning that they're not rising in altitude, they're dropping in altitude. So Kansas could be 2,000 feet, in 2016, in 2020, 2030, 2040. Kansas could literally be 1,500 feet, maybe 1,000 feet. No one will ever notice it, but you won't know until like maybe there's a serious rain. I mean, if you look at the climate activity for the past 5 years, it's been flooding in areas it has been flooding in decades before. I mean, there are areas being flooded in the United States that should not be flooded, and that should give everyone. What the hell is that? Okay, that should give everyone the immediate clue that when you see when you see an entire town in West Virginia become flooded from torrential rains, it has nothing to do with poor infrastructure design. It has to do with man, why does Robert resist fixing his mic? I appreciate that, man. Hold on for a second. Stand by.
I just wanted to say that if I made a mistake, it was out of ignorance. I do apologize. It was not me trying to trick anyone. I guess the way that I see it is from a layman's perspective, because I didn't go to college or anything like that. So I'm just trying to explain it to where other people can understand it without complicated
Don't worry
stuff.
about it, Hank. Hank, there's nothing to apologize for, dude. You don't need to go to college to explain things from a logical standpoint. We can all, I mean, it doesn't, this is not, a measurement of intellectual capacity, man. I mean, we're expressing this from a logical standpoint. So what I was rooting to was that if you take the United States in particular, and then places in the UK and other countries, yeah, the weather's been changing, but if you look back into history, there are times where the weather was even worse than what it is now for the past decade. But there are places that never used to flood the way they do, where the water is collecting, just like Robert Shortman says. Somehow, the rain has caused erosion of the terrain, and you lose that efficient flow of the infrastructure system and wherever you may be living. But after you fix that problem and you still have the same problem 2, 3, 4, 5 years later, and you're thinking, wait a minute here, why is the water still collecting in this area? The reason why the water is still collecting in this area is because the pressure is being increased on the earth, meaning that the land masses we believe to be as flat as they are, like Kansas is supposed to be the flattest place in the United States. It's flatter than a pancake. Well, when I hear that Kansas is flatter than a pancake, that means that eventually Kansas will become a concave fucking state, meaning that water will just collect in there like a cereal bowl. Everything is undergoing flattening, and there are places that are flat that are getting flatter and then will become concave, and there are places that are not as flat that will become flat. I mean, this is described in the in the Bible as well, as much as I don't like using it for religious purposes. But when you look at it from a scientific perspective, they talk about this in the Bible, on how mountains will just be flattened and wiped away. They're talking about literally the earth just being popped like a fucking zit.
Well, hey, Robert, you might be able to just chalk that up to erosion over time, too, though.
Well, I mean, we could talk about, erosion over time, and people will try to use the weather to say, it's just a natural occurrence, that's how things are supposed to happen. No. When you look at the International Ellipsoid Reference, and then you compare it to what was been going on with the weather in specific areas of the world, where they didn't have those problems a decade ago, you can't just say, the water is doing that. There's something going on with the rest of the terrain, because here's the thing. If you've got a lot of hills and bulges in the areas you live, and it's soil that's been softened up and it's eroding, well, guess what? All of that settles down to a level area, just like water does, right? So if you live in a hilly or mountainous area where there's a lot of dirt and rock and whatever and sediment, all of that comes down to a level plane, and then eventually you don't have that problem anymore. So the more it starts to rain, you have erosion, then you start building up hills and valleys and mountains again. So now, when it starts to rain, instead of the water coming down and collecting in a center area where there's a concave type of bowl pressure, you got dirt and sediment and everything filling up that area. So now the water can run down from the sides instead of running down into the center. So there's going to come a point to where everything will just level out and flatten out, and then it'll start to build back up again, where the water will run back down into the oceans and lakes and wherever else they go. Water will find this level plane. The only place where there's a level plane where water finds that is in the oceans. Now, my question is this. The information Hank brought up with regard to, comparing the distance with the potential possibility that the altitude could be higher on a globe. When I spoke to him, I took that as though maybe they were trying to point us to data to say they're not measuring from sea level. They're measuring literally from where they believe the bottom of the ocean is up to where Kansas could be. And that's where you get that bigger number of over a million feet. A million feet. Because the bottom of the oceans have to be level for the waters to be level. They're not on a ball. It just can't. That much volume and mass of water, I don't give a shit. I don't give a shit if somebody's saying we rotate at 1,100 miles an hour. As big as the Earth is, you'd have to be rotating way faster than that for the water to stay the way it is. You'd have to be rotating faster than that. And the Earth's not 25,000 miles from the equator. See, people, they don't even know where that measurement actually starts from. The measurement doesn't start from the outermost layer of the Earth. The measurement of 25,000 miles in circumference starts from a fixed stationary landmass position of the land masses, not of the entire Earth. The entire Earth could be 5 to 10 times bigger than that. But they're telling us, oh, we're only going to measure what we want you to know exists and you can see from the air. We're not going to tell you where everything else is at. I mean, come on, think about this. Why the hell we don't have an airplane that literally can fly nonstop around the entire world on a flat plane? You got to jump from one place to another, to another, to another, to another. You can't just fly a plane around, and some sort of elliptical pattern and just map the whole thing within, say, 30 days. They don't allow you to do it. They put a 50,000 foot. They put a 50,000 foot
flight ceiling kind of thing.
Flight ceiling over commercial aircraft. Why won't they let you fly over 50,000 feet? I mean, hell, the U-2, their operating altitude, the floor is 70,000 feet. They won't tell you what the ceiling is. If you go on Lockheed Martin's website, it says it can go in excess of 70,000 feet. But they don't ever show you any footage of over 70,000 feet with the U-2. They show you taking people up at 70,000 feet. They don't want you to go any higher than that. The Russians they'll take you up there for $75,000, $150,000 to 80,000 feet. But they don't keep you up there for very long. You're up there for maybe a few minutes and they come right back down. They come right back down. There's a reason they don't want to show you this. And everyone will say, hey, the Felix Baumgartner jump was all fake. It was staged. It was green screen. Okay, I will agree, and then I'll stay neutral on it at the same damn time if that's possible. But think about this. We all looked at that footage. This guy's supposed to be over New Mexico at 127,000 feet. New Mexico is fucking huge, dude. If that video was real, you couldn't see any other states. You couldn't see anything else. And according to what some scientists had did and mathematicians who talked about this relating to flat Earth, they're saying, wait a minute, if the Earth's rotating at 1,100 miles an hour, the amount of time that it took him to go up to 127,000 feet and the amount of time that he was supposedly stationary at that altitude, and then the amount of time it took him to literally come back down to the earth, this dude should have parachuted over fucking California. From New Mexico, where he took off, he should have landed in California. But everyone wants to dispense with the idea that that was actually real.
Well, because that's where science collides with belief. Those people believe that the atmosphere, the water, and everything spins with the physical ground that we're supposed to be on.
Yeah, I mean, it's obvious. We already know the Earth is not, the ground we walk on is not rotating. I'm not going to say the Earth, because if I say the Earth, everyone takes it as a general term. When I do say the Earth, I want everyone to understand I'm talking about the ground I walk on. That's Earth. It's dirt, rocks, dog shit, pebbles, nanodiamonds, whatever.
And that dog shit.
You know? But when people, if you want to speak in the general terms, the Earth, the landmass we live on and work on is not rotating. The outer atmospheres are. That's obvious when you look up in the sky and you see those star trails. I mean, we're starting to question all that shit now. But I want John, if he's still in here, we're going to bring up the information on the railgun. So John got that information. I got a document. I can pull up that document, John. You just show your information and do the share screen, because that's the second piece of information we want to provide with regard to another solid data. Because Hank's information was very good as well. Hillbilly came in and made some corrections on that stuff. But both pieces of information are good. We want to go with the railgun because the Navy says they got a railgun that can shoot something from 100 nautical miles. And understand, people, there's a difference between a nautical mile and a regular statute mile. So go for it, Jay.
Yeah, am I sharing my screen?
Yeah, I'm presenting you right now.
All right, we already went over this before, but let's do it again.
Hang on, Jay. It's not up on the watch page. There you go. It's up on the watch page.
Okay. Like I said, we went through this before. I guess we went through it a little bit too quick. Let's try it again. See, naval railgun. The projectile travels 5,600 miles per hour. That's Mach 7. You see this thing right here? This is more or less a rifle that fires a bullet. Okay? As we said before, this has a range of 125 miles. Right? It's right here. We showed the video. They even pointed out, they themselves, the ones that designed the railgun, are just they're showing you a shot from Washington to Philadelphia. What's this number here? 125 miles. So we could put that to bed, right? It doesn't even matter. We can go down to 110 miles or 100 miles. It makes no difference. So, this is a line of sight weapon. They're not going to say it's a line of sight weapon because it's inherent. They're not going to tell you that a rifle is a line of sight weapon because it's a duh, because it's a rifle, right? We're going to put the railgun 100 feet above sea level. That's right off the deck of a destroyer or a cruiser, and I'm even given the benefit of the doubt with this because I think it's much lower. And according to Mark, it's like 30 or 50 feet. So I'm given 100 feet. So more than enough breathing room here. So, as I said before, a target at 125 miles, we can go ahead and pull off the calculator. Right? So, the distance is 125 miles. The viewer height, or the height of the railgun, is 100 feet above the deck, above sea level. So, we're going to calculate again. So, the horizon distance is 12.25 miles. The hidden amount is 8,476 feet. The key one here is this bulge height. And like I said, you go down here. This is where the railgun is on the ship. So this bullet has to go from here to the target at 125 miles. It has to ascend and descend at Mach 7. Now, anyone that can fog a mirror knows that this is impossible. I don't know any other way to put it. Okay? I can't break this down any further. So let's employ some actual science. So like I said before, we went over this a few times in past videos, the null hypothesis. To do a hypothesis test, you will actually have two hypotheses, the null and the alternative, which are stated in such a way that they are mutually exclusive. Makes sense. The null hypothesis is the conclusion that is considered the default. You will accept this hypothesis if you fail to find sufficient support for the alternative hypothesis, right? So, the null, if the Earth is flat, then shots taken with a line-of-sight weapon, a non-self-propelled projectile, it's a bullet, will not be limited to the Earth's curvature. Bulge and target hidden amount to effectively engage targets for said distance and elevation according to the alleged curvature, which we've just shown. This is the ball earthers hypothesis. They need to validate this. By validating this, they falsify this. Make sense? This is their hypothesis. If the Earth is a sphere with a circumference of 24,901 miles with a radius of 3959, then shots taken with a line-of-sight weapon, it's a non-self-propelled projectile, i.e. bullets, will be limited to the Earth's curvature, bulge and target hidden amount to effectively engage targets. So, they need to prove this one, validate this hypothesis, whereby falsifying the null. You have to falsify the null. If you can't, then you're finished, right? Scientifically speaking. It's already been validated. They've already said it. It has a range of 125 miles. They've already tested this, as you can see here, for the 1,000th time. The Navy helps to use the railgun for multiple missions, including precision, surface fire support. We'll see that here and again in a second. Land strikes, cruise missile, and ballistic missile defense. The weapon will also be used to fight surface ships. Surface ships are on the surface, right? This weapon, Dr. Roger McGinnis, he's the executive in charge of the railgun program. The weapon does all of its damage because of its speed. Speed. It can't be an indirect fire weapon because it's a bullet. It has no explosive. See this? The weapon is called a railgun and requires neither gunpowder, nor explosive. It is powered by electromagnetic rails that accelerate a hardened projectile, it's about the size of a football, to a staggering velocity. Here it is again. It uses no gunpowder or chemical propellants. It's good in a sense for the Navy because it eliminates the need to carry dangerous explosives on the warship. Here we go again. The 25-pound projectile is a non-explosive bullet. Everyone say it with me. Non-explosive bullet. The incredible speed allows the projectile to strike the target with enough kinetic energy to destroy it with no need for explosives. See that? Now, the naval fire support, we roll down here to naval gunfire characteristics. Naval gunfire has a flat trajectory. So, as an indirect fire weapon, like artillery, will they use HE or high explosive or incendiary rounds? The Navy railgun projectile is non-explosive. It does all of its damage due to its speed for the 1,000th time. Using it as an indirect fire weapon, the projectile will lose most of its speed and drop a piece of dead 25-pound hunk of metal from the sky. That's really scary, right? I'm sure the Navy's not going to spend $1 billion friggin' to drop 25 pieces of dead metal anywhere. This is tantamount, if you say it's an indirect fire weapon, this is tantamount to claiming that an M16 or M60 or another rifle is an indirect fire weapon. Okay? Is there any questions about this? I can't break this down any further. I really can't. Go ahead. I'm done.
You know, it's interesting because I want Mark to go ahead and make everyone laugh on the math you did, Mark, with regard to if the rail gun was being fired on a round Earth. Tell everybody where the rail gun would need to be located if it was on a ball.
Well, to go as far as, was it 120, 125 miles, it'd have to be 9,600 feet in elevation to shoot a straight line. And going back to what John was saying about it being, it's the speed that's the key.
Exactly.
If you're shooting something with a 15-degree up angle at Mach 6, Mach 7, whatever it's supposed to be at, it's going to go further than 125 miles.
Exactly.
And that's the key. It's a flat trajectory weapon. It uses that speed to go 125 miles in almost a flat trajectory because it needs that speed in order to go 125 miles in a flat plane. So you can't say that you're going to shoot something at Mach 6 and put a 20-degree up angle on it.
So is it using line of sight targeting then to aim at the ship at 100 miles, which I think they've got this technology to do that. They're either sophisticated pinpoint, cone radar that will actually focus into that point at that distance. So it
all you need is a bearing. You don't need to calculate an angle.
So they just aim. They say it's at that bearing and bang far, and it just travel at that distance straight at 50 feet, 100 feet.
Boom, D4, you sank my battleship.
You sank my battleship.
That's exactly what it is. Boom.
That is basically what it is. I've heard people. I had mentioned this before on some other channels, and people like, oh well, it's going through the Newtonian, laws of gravity, and it's just got enough velocity to keep falling around the Earth. Yeah. I'm like, look, man, what the fuck don't you understand about line of sight? Do you know what that means? That means you can see what the hell you're shooting at. Binoculars don't see around corners.
Well, Robert, pull the Metabunk thing up to where you can input the data, and we'll put that 9,600 feet in there.
I got it. What do you want?
Oh, I got it.
Just put in viewer height, because if you want to go the distance to the horizon, because basically you're shooting a ship on the water, you're shooting it basically at the horizon as far as you can go, correct?
Yeah.
So if you punch in 9,600 feet, there you go. The horizon distance is 100 miles. So if you're trying to shoot it straight, that's how high you got to be.
So there you go. If you were on a ball, you could shoot. If you were on a ball, that's basically what Mark is saying. It's not basically. If the rail gun was on a damn basketball, that rail gun would have to be bolted to the basketball at 9,600 feet to hit a target 120 miles away.
Hey, maybe they got one of those flying aircraft carriers like in Captain
America. No. Some people will say, well, yeah, they got these big, 60-millimeter guns that you can put on C-130s, the airships. No, you're not going to put a rail gun on a C-130 airship. No way. Because as soon as you fire it, the whole aircraft will explode.
Yeah, you might be able to put a small, like that guy built that 27,000 joule railgun.
Yeah, they couldn't put that damn thing on an aircraft.
But all he could do was put it through the outer shell of a car door, through the window, but it didn't penetrate into the car, and that was from about a distance of 10, 15 feet away.
Yeah.
That's 27,000 joules. So imagine what you would need. Yeah.
What I want to talk about is this. Because we're back on this topic, talking about the construct and design and visual confirmation of the Earth. And it dawned on me why over 7 million people still believe the Earth is round. Okay, because the views that are being shown to all of us, the majority view has been from high altitude. And if 7 million people were allowed to see the video I put out, that there's multiple layers above our heads that give off a view, a perceptual view, that there's curvature to the earth. You got 7 million people who are just summarily agreeing and confirming, yes, the earth is a round ball, because I've seen the curvature at high altitude. But when you tell them, okay, then what do you see when you're standing on the ground? Well, of course it's flat. See, they're saying we have confirmation bias, right? But it's 7 million people who have confirmation bias, because they'll admit that when they're standing on the ground, they can see for as far as the eye can see on a clear day, right? But when they're at high altitude in a plane, or they've seen some video footage and you see curvature, they're not sure if they're seeing the furthest distance edge of what could be some sort of curved type of object, you know, or they're looking at atmospheric lensing, where the light's being bended to give them the appearance that the rest of the earth may be a ball. Because when you look at high altitude footage, you can't see, you can only see the horizon line. And even then, the horizon line you're seeing, you don't know how much further it could actually go at high altitude. You just can't see it. I mean, I always thought in the beginning when I started talking about this that Antarctica was the outer ice edge, because the blue hue, the blue and white rim hue that I was seeing from a distance at high altitude, it was similar to what you see in the cryogenic environment. You see that cold cryo air rising in the atmosphere, which gave you that blue hue that the Earth has. That's what ice does. Robert Sherman can tell you that. Yeah. He and I were talking just the other day. He says that the ice in Antarctica is like basically void of oxygen and any gases, and it's the bluest ice he's ever seen. It's like rock solid petrified blue.
Yep, it's pure blue. If you can probably Google that type of thing, and it's just deoxygenated ice that's been in the ice shelf for such a long length of time that it gets compressed to such a level that it compresses the oxygen out of it, and instead of it being white or transparent like normal ice is if you just chuck it in the freezer, it comes out blue. So you get that blue hue from that naturally as well.
That's interesting. I mean, that's definitely an experiment worth testing out to see if you can literally freeze ice yourself to make it that same color blue.
Hey,
if you
Robert,
can remove the gas from it.
Robert, before we move on, I would just like to say that beyond the subjective, this is objective and empirical. What they have to do is validate this. If they can't validate this empirically, then it's over. We can move on to discuss other things.
And you're right about that, because I've been looking for the documents for literally 20 years. When I first learned in school what the circumference of the Earth was, the first thing I wanted to do was show me the document that proves exactly how this measurement was obtained. Where did they start?
Well, that went back to Eratosthenes, right? But his was based on a presupposition that the Earth was a ball. If you remove that presupposition, then what do you got?
Well, I mean, and I understand where you come from, but here's the thing. There was information that I ran across where his measurement was actually misinterpreted, and it puts the Earth at 250,000 miles in circumference.
No, he was correct. He was correct. However, he was basing it all off the presupposition of a ball. If you remove that presupposition, then it all falls apart, because you haven't isolated any independent variables, because the cause of it can change. If you had a flat Earth with a small sun, well, guess what? You get the same result.
Yeah.
So his presupposition, everything's based on a presupposition.
Aristophanes' data, I mean, it's just incomplete all around. I mean, there's no way this guy could have known.
Well, it's a begging the question fallacy.
Even with him assuming it was a ball, he starts in his region, gathering some measurements. What was the distance when he did the stand?
I don't even remember.
Huh?
Oh,
I don't remember.
Points. It was like 200 some miles at least.
Yeah. So he used the Standia method. It was basically the distance a camel could travel from one city to another. That's what he used, the Standia, right?
I think they were using some form of Skype to communicate between each other back then.
Yeah, right.
How are two people hundreds of miles apart going to communicate to do something at the same time?
No, well, I don't know how he did it. I honestly don't know how he did it. But he used this measurement that I had used with Jeff, and we did that calculation, and for me, it's still inconclusive because I can't find any other data where someone actually replicated the experiment in the 19th, 20th, 21st century. No one's done it.
Without using
no one's tried to replicate the experiment.
Without using a communication device.
Right, that's the same thing with the Cavendish experiment. Find me one experiment that repeated it exactly the way he did it. Good luck.
They can't do it. They can't do it.
Nope, it doesn't work.
It's not science.
No, they can't do it. So, but we're still using that science today to keep telling people that.
No, that's not science. That's not science. They're labeling under science, but that's not science. That's pure conjecture. That's philosophy or religion.
It's propaganda.
Yeah.
I mean, when you, if anybody. If you've been up in an aircraft, like I've been up in a private aircraft, I've flown a Cirrus SR-22, and I was about, 10,000 feet average, put it on autopilot, right? We're flying in Carlsbad, California, and the distance from Carlsbad, where we flew to Temecula, it's about a 2-hour drive, but it was about a 30-minute flight. 30-minute flight from there, and even at 10,000 feet, I don't know how big California is, but let's just say 25,000 miles in circumference. Man, you can be up at 35,000 feet and see more land, more square miles of land than that. You can't tell me the Earth is 25,000 miles around. I've never believed it. When you look down at the Earth on your next commercial flight, anywhere you're going to fly, just try to develop a precog visual picture of what 25,000 miles looks like. Okay? Just do a 25,000 mile radius of where you live. I mean, that's the easiest way to do it. Pull up a map, Google Earth Pro, and pick anywhere on the map where you live. Use the tools, the measuring tools, and then zoom out that circle to do a 25,000 mile radius. And I guarantee you, based on that 25,000 mile radius, you tell me if the Earth is really 25,000 miles around. And I'll tell you here right now, if you say the Earth is 25,000 miles around, I'll put you on my health insurance policy to get your fucking eyes checked. Because there's no way. There's no way. I don't understand how they got people still believing this. I mean, even the fake footage they show online with NASA, when they show these aircraft at high altitude, I mean, how do people really have no idea where they are? Where they will believe this?
They blindly believe assumptions.
The amount of people that just don't care is staggering.
I want to show everybody something. I pulled up Google Earth Pro. And I want to
Hold on, let me get out.
Robert, can I say one thing? So I got to go.
Go ahead, brother.
And I don't know if I'll be back by the time you guys are finished. I know we've talked about it a couple sessions ago about measuring the distance to the moon and stuff.
Yeah.
If there's anybody out there who's listening who lives in the southern hemisphere that has to look to the north in order to see the moon, okay, we have a northern view of it, get in contact with us, because we've got enough people in the northern hemisphere. We need at least 1 or 2 people in the southern hemisphere to make this experiment work. You have to be able to measure bearing and angle, azimuth, to the moon. However you can do this, sextant, telescope, whatever means you have is good enough, as long as you can measure the bearing to it and an angle up to it. Okay? So that's all I got to say.
Okay.
All right.
Since we're on the subject of the moon, can I say something real fast?
No.
Solar eclipse. If you type in the solar eclipse for 2017, you'll see that the solar eclipse always have a very small window of about 100 to 200 miles. Now, if we're talking about a moon that is 1/4 the size of the Earth, I'm asking this question: how do you cast a shadow on the object and that shadow be smaller than the object itself?
Impossible.
Yeah, that's outstanding.
I got a quick tidbit about that 25,000 mile radius here. In a 25,000 mile circumference, the diameter is close to 8,000 miles.
Okay, now check this out though. I've got Google Earth Pro pulled up right now. Can everybody see this?
Yeah.
Okay, now look up at the left-hand side, right here where it shows radius in feet and area in square miles. Now, every damn space agency, the USGS, US Navy, whoever, Google, they're telling us the Earth is 25,000 miles in circumference. Well, let me show you something here right now. This is the measurement tool for Google. So if you want to debunk Google, you debunk them. Don't debunk me. I'm using their shit. Here is 25,000 square miles. Right there, give or take. 25,676.83 miles. People, that's not even fucking covering Kansas. That's 25,676 miles. Now that's not even.
Yeah, but Robert, you're using square miles.
Yeah, and that's what I said. They said the Earth is 25,000 miles in circumference. Okay, you want me to change it? All right, let's do it. Let's go to when you want me to go. Well, I can only go nautical miles or miles.
Go to
Let me use nautical miles. Hello.
No, you're using square miles. That's what's throwing you off a little bit.
Oh, rather it be a little bit or a lot. Square miles.
hold on, the circumference. That's what you want to look at, the circumference. It's right up under it.
Yeah, let me change.
Okay, so let me see here.
Go to, do this. I want you to change that circumference. I'm going to go to 25,000 square miles.
So,
All right, let me go to there. Now type in 2,991,659 feet. Convert that to miles. What do you got?
20, hold on a second. Oh, hold on. I got you. Okay, 25,000 miles to feet is...
No. Take the circumference of 2,991,659 feet. Convert that to miles.
Okay, I'm going to say 3 million. Feet to miles. $568 miles.
Okay, 568 miles. That's what you got?
Yeah.
Okay, let me keep going. We just keep going.
That's why I want to. Okay,
Hang on, let me keep going.
take 25,000 miles to feet, right? This will tell you how many feet you need.
Okay, what do you got? Enter in this number. Enter 38,532 feet. 38,532,000 feet. Enter in that.
Okay. Miles. Okay. You got 7,297 miles.
7,000?
Yeah.
Okay, let me keep going. So we already got the United States covered, right? So check this out. Let's keep going. Let me cover all the United States.
Instead of guessing, I just converted 25,000 miles to feet.
How many feet is it?
Okay, so it's 1.32 with 8 zeros behind it.
So it's billion. You said one what?
1.32 E plus 8. Let me try to get the long number for that.
Yeah, see, that don't make no fucking sense right now. That's crazy. You can't even, they won't even let you measure that shit on Google Earth, bro. They won't even let you measure that.
The calculations don't add up with their own calculations, do they?
Holy shit. They won't even, I can't go any further.
Because it doesn't matter.
I can't go any further. I can't even go outside the Earth. I can't even get the feet measurement that he just gave me. You can't even go outside of the Earth to measure it. What else do I need to do? There's nothing else. I can't even go outside the Earth, man.
That's only 131 million. Hold on. That's only 131 million feet.
That's what I'm saying. The number you gave me for 25,000 miles into feet circumference.
Yeah.
In feet. I'm only at 131 million feet.
1, 2, 3, 4, 5, 6, 7, 8. It's supposed to be 13,200,000,000 feet.
Oh, great. There you go. End the fucking story. I don't need to argue that.
Damn.
End the fucking story. I don't even need to go in anymore with that shit. Then that's the end of that one. That's it. You guys saw it for yourself.
No, it was
Fucking
right. It was right. 132 million feet. 132 million feet. I did it wrong. Okay.
Yeah,
Oh, dude, come on, man.
it's still short, way off. It's still way off.
It's still way off, man.
It should be exactly accurate if they're trying to base it on the maths they're basing it in the first place. They can't even get that
There you
right.
go. The maps are not right, man. Yeah, see, that propaganda says that 131 million feet is 24,000 miles, 24,810 miles.
That's what Stephen Hawking tried to do. He used all math.
So where the hell is the rest of? Where's the rest? How are they rounding up to 25,000 miles? Where are they getting this number from? That's what I want to know. I've been searching for the original data. Where are they getting this number from?
It's supposedly some plane flight around the equator. Some famous plane flight that some ballhead said, we have measured the equator. Somebody circumnavigated the Earth.
Okay, yeah, flying at what altitude? That's my point. Because here's the thing. They weren't on the ground, of course, so they were in the air. So at what altitude did they determine, okay, we're going to fly at this fixed altitude to go around the equator? See, what they're not factoring in is this. If you're flying, if we took off from Ecuador, right, to get up to, say, 25,000 feet, you're going to travel maybe, what, 10, 15 miles? before you get to 25,000 feet. Because you're not just going to jump straight up to 25,000. So you got to factor in the distance you travel from the time you took off from that airport to the distance you travel to get to 25,000 feet, and then you begin your measurement. But you still, when you're done, you got to factor in the distance you traveled as soon as you took off down the runway, got up in the air, and you hit 25,000. You got to include that distance as well. Unless they flew around, they had some sort of fixed longitude and latitude device that said, okay, boom, we're at 25,000. Let's start the clock right here. Let's start the measurement right here because we're at 25,000. But let's remember, we got to fly back to this same position to get an accurate measurement. They didn't do that. They flew, whatever aircraft they used, they flew from one place to another, leapfrogging, and just came up with some mean average number to say, okay, it's 25,000 miles of circumference. Because the higher you go in altitude, all right, the further you'll be able to go.
The plane's going to be limited in range as well, so it's going to have to be stopping at all these most convenient airports or places where it's refuel, which is mean it's going to be a whole zigzag thing all the way up to where it is. How can I calculate from that?
Exactly, Robert. They weren't flying in a fucking straight line. And they weren't flying in a fucking straight line. This is, man.
I'll put a link in the side chat right there.
Damn, dude, I'm so confused, man. I just want to go to another planet, man. Damn. Because this place is all fucked up, man. We don't know what the hell is going on, dude.
Hey, but wait a second, Robert. Was it flying east or west?
We don't. Who knows, dude?
Well, the equator, at the equator, it's supposed to be spinning what? At 1,000 miles an hour, right?
1,000 miles an hour, which means that they had to have been flying real fast.
Well, before it could get to its destination, the destination would come up on its 6.
So all they had to do was just stay in one place on a balloon.
Watch the world go by, yeah.
It'll never get there flying east.
Yeah, that's true. Because that's all he had to do was just put a balloon up in the air and say, just give it about 30 minutes. We'll get the measurement. We'll be back down.
Yeah, it's gonna bum rush him.
You know? I mean, this is crazy, dude. This is just absolutely crazy, dude. Hang on for a second, people.
That's what Picard had supposedly did in a balloon.
Yeah, he went quite right, didn't he? 10, 11 miles.
Let me see. 46,000 feet, I think.
I think Picard went up to like 57,000. 1 second.
Let's see. On the link I'm looking at, it doesn't say.
Yeah, 1 second, I got it.
Right, so
51,775 feet on May 27th, 1931. And what did he say? It said, through the portholes, the observers saw the Earth through copper-colored, then bluish haze. It seemed a flat disk with an upturned edge. That's from Popular Science magazine, 1931, 10 miles high and an airtight ball. There you go.
Observation and repetition. You can repeat these things. You see, the rest of these things are just theoretics.
I never even heard of Picard before, other than Star Trek.
This is again balloons you can repeat, whereas this circumference nonsense and size of it, you know, how can they measure that? And knowing what we know now, that it's just pure nonsense. The size that we're working from and the dimensions that they're giving us, it just doesn't make any sense at all. I mean, if they knew it then, it was pretty much hidden again. They thought, oh well, we'll shut him up. He's discovered that what the world looks like from a height, and ever since then they've always used those manipulated cameras that don't show the true perspective of what you're seeing naturally. Yes, the human eye is kind of convex, but you can still represent what you're seeing physically without the distortion, without the wide angle, without the fisheye lens. And the NASA thing, well, that's just unbelievable with the footage on that. It's just completely rubbish. And it's clear why they're finishing it.
You know, a while ago you asked why so many people believe in the ball, and I find that what they do is they take evidence that disproves the ball, and they flip it around on us and say that it proves the ball. So we don't ever think to counter it like that. For example, back in the day they used aluminum foil to make their spacesuits, and when we call them out on their bullshit, they often say, "Oh, you're wearing an aluminum foil hat. Take off your foil hat," and they do this all the time.
Yeah, they just they throw conjecture every time they want to speak. So you say black, they say white, you say white. They just keep kind of coming at you that direction. Whereas if they really actually check for themselves, they'd see what they're saying was rubbish. And if they checked the details and did a bit of research, it would, you know, they'll come up with a different answer. But they don't want to see that. They just want to kind of believe everything they've taught. Believe all the health things that they've taught, and it's a shame. They just need to
But,
do a bit more research and check these things out rather than
but,
just take.
but once you support your claims with the actual scientific method, then there is no answer. That's why they call you names and bring up silly stuff. But once you post it empirically using the actual scientific method, then it's over.
Yeah, agreed.
See, they don't want us to get past the arguing stage because there's some ramifications with this lie that they've been promoting all this time. Okay, so there's a readjustment, and redressing that has to happen.
No, they don't want that. They want to keep pushing it as long as they can. So again, by getting rid of the International Space Station camera and removing that, it means that they can push other productions into force, like the Mars thing and all, that type of preparation, and the rest of their kind of fake footage that they like to push. It's just easier not
Yeah,
to have that footage.
they've been committing fraud to the tune of $5 billion a year, NASA,
And I think
and
because
all types of other madness going on here.
they're getting called out now, they're kind of starting to think, wait, we're getting a bit too much attention, and people are actually seeing it as for what it is. And when they do these live things on Google, there's been lots of flat Earth people that actually come in and say, well, no, this is not actually correct. And I think they wanted to keep pushing that as long as they can. And now it is actually gaining more attention. They're having to kind of back off and say, right, well, we won't film this footage, and then they won't be able to call out where it is, when it is, and looking at how rubbish the model they actually do use for that is.
So I've been hanging out in the debate room, and I noticed that one of their best things to say is, well, how does the eclipse work? On the flat Earth, and then when you show them that the moon is supposed to be 1/4 the size of the Earth, and the shadow on the Earth is 100, 200 miles tops, well, it should be 6,250 miles if that was a real shadow. And they say, oh well, it's refraction or diffraction or something like
Anywhere
that.
from 3 to 6,000, that kind of distance and size, where you'll get the actual shadow if you fire a direct light source at the moon with its perspective size in front of the Earth.
What is the shadow refracting?
Yeah, that's exactly what I was saying. They take stuff that disproves what they're saying, and they use it against us. They always flip everything around, like the Coriolis effect. They say, well, that proves that we're on a spinning ball, but when you bring up the Felix Baumgartner jump, and he landed 70 miles away, he was up there for 3 hours, it should have been 2,100 miles away.
Well, simple plane flight destroys that. We already went over it. But with the lunar eclipses, how do you explain the sun and the moon being above the horizon on a lunar eclipse?
They can't explain it. Nobody can. It's because it's all got to be closer, like I did in that video the other day.
It's got to be.
Yesterday.
And
Everything's got to be closer.
yeah, and because if you use the ball math, right, when you triangulate the sun, it comes up to close to 3,000 miles high, and
That's correct.
about 30 miles across. So we all know that that's impossible, man. We found that much out. So it has to be a lot lower, and the Earth has to be much, much huger.
You know, and the next thing I want to talk about with you guys, and it's just I'm reaching out. I've been trying to locate virtual online experiments, and I discovered something in the process of searching. I wanted to validate that science that I put out. Well, actually, it wasn't science. It was an experiment that European Cellular Observatory conducted with a 22-watt laser shooting it up into the atmosphere, and they hit what they call the sodium atom layer at 90 to 110 kilometers. Well, I went into my online library I have for the stuff I do for the classes I have now, and when I clicked on the mystery substance and I tried to enter in the refractive index for sodium, I went to look it up. I couldn't even, they wouldn't let me type anything less than 1.0. So I went looking at other universities to see if they had any software. You won't believe this. They list all of the elements, gases, liquids, any other type of solid material matter. Guess which substance is not listed that you can add for environment or material medium when you're firing a laser? Sodium. You couldn't enter in sodium because the refractory index can't be measured when using light. Now, I don't know what that proves and what it doesn't prove, but I can tell you here right now, if they hit that barrier at 90 to 110 kilometers, that means a 22-watt laser, even if the laser was capable of being dialed up to 30, 40, 50 watts, that means there's an impenetrable layer of sodium atoms at 90 to 110 kilometers. And then it dawned on me, if there's an impenetrable layer of sodium atoms where a 22-watt laser can't even get through it, how the hell are rockets going through this sodium atom layer? Does that mean that the actual Kármán line is not a line where space actually begins, and that's where Theodore Kármán and all of these physicists had agreed back in the 1930s when they got together for the, what was the international, it was called the International Science Year or something like that. And they all agreed that the international standard where space begins is approximately, they don't say exactly, approximately 100 kilometers. When I went through the data again, I had an epiphany. That's not the line where space begins. That's the limit to where we can go. That's the limit. That's the ceiling. You can't get any further than 100 kilometers.
That's why.
And when you have atmospheric expansion, maybe you can get to 110 kilometers, but there's nothing beyond that. You can't get beyond that level. That's the only logical explanation that I can come up with personally on why a 22-watt laser just suddenly hits a barrier of sodium atoms. You get them excited and they glow to create an artificial star.
Yeah, that's probably why the rockets curl off and do their parabolic arc.
Exactly.
They can't
Exactly.
do it. They can't go up there, and if they did, it would, it would go up, hit, and blow up, and come back down, and they know that.
Exactly. And get this. Do you know that in NASA's documents, the number 33 and 45 is in there? Now, I don't want to play semantics with numbers, but get this. If a rocket takes off, you got an initial 90-degree vertical lift, right? And then as it continues to gain altitude and acceleration, guess what trajectory it takes? 45 degrees. Guess what angle they claim the sun is shining its light? 45 degrees. Guess what angle the sun is potentially, the moon. They list that at almost the same angle, which means everything is within some sort of curved dome, and you've got to get to that 45-degree angle or you're hitting a fucking brick wall.
Yeah.
You're hitting a wall. Because when I talk to that airline who does those civilian flights down in Antarctica, they wouldn't even answer my question on what altitude that they are at before they hit Antarctica and they have to drop to 10,000 feet. She didn't even want to answer the question.
Hey, Robert.
Go ahead.
Robert, Robert that's on the call, he's been to Antarctica, correct?
Yeah, he's been flying aircraft. Ask him. He's been in aircraft.
Yeah, I did about a week or two flying out there in total. So yeah, the heights they say on Google Maps don't match up with the heights that I was landing and flying at in certain places, because I looked at the places and then thought, because they give a supposed topographical height and where you're meant to be and what you're looking at, and some of the places didn't match up, and I thought that was pretty interesting.
Did anything else stand out to you? How long did you stay down there?
About 18 months altogether.
Oh,
About
wow, that's long.
13 months at the main base, and then did about 2 or 3 months traveling around the peninsula.
And what was the main base?
Halley.
Halley?
Yeah, it's British, the British most southern base that they have there.
Okay.
The other ones are based on the peninsula and the islands dotted around it.
Right. Does anyone go into the interior?
No. And those who are, that is kind of controlled. Well, it was.
Yeah, that's what I figured.
Yeah, they just let the top brass go down there. No one else.
Shocking.
Way of doing it on purpose, because then you've got the most controlled and the person that's never going to say anything anyway go down there and then just do, supposedly go there. It's to hide the stuff that they've got.
Hey, Robert, I wanted to ask you too, and there's always been a question that was, I'd always forgot to ask you. Was there an altitude ceiling in Antarctica?
Yeah, but the altitude, because it was a non-pressurized aircraft, it was kind of, once you get beyond 14, 15,000 feet, it didn't really go much higher than that. But yeah, the highest I got was about 14,500 feet, flying about just under 1,000 feet. So the ice was about 13.5, 14,000 feet below me. So I was literally kind of going above that to keep it, So yeah, that was pretty interesting. Yeah, it was all flat pretty much, but sloping up from the edge of the shelf wall, which runs all the way around. So there is a shelf wall, but within those walls you have a breakdown where the ice breaks actually off, and you can actually just get like a bulldozer and just shape the slope down. So that's what they use to get vehicles and stuff in and out, because you just wouldn't be able to do it if you had to try and get it up a cliff. That would be it. Other bases are different. Other bases have more of a rocky kind of area, but again, they're all based around the edge of the ring. There's not the only ones that really are central are the US controlled one, and it makes no sense with their map that they use, which is that pie chart that everything leads to the middle. Because in that theory, then every country owns a section or overlaps a section that they own and has the ability to go to those places without restriction. But there is restriction there, and it is controlled.
there is one piece of pie that's been left unclaimed, but it's mostly when the ice melts, it's just nothing but open water, and that's what got me at calling NASA to ask that question: what was wrong with the satellite coverage over that center area, and why was it black? And they never got back to me. And then Bob put out that video with Globebusters that Antarctica was actually two separate land masses, and at the center, between the center of the both of them, in the winter times, it just ices over, which gives the appearance that it's one single landmass.
I think when they flew their high altitude camera balloons or the aircraft with the cameras sticking out the back, they've neglected to put that bit of footage in Google, because it would show where these areas are. So they purposely kind of black it out, or keep the image distorted or completely irrelevant, so they just clone the whole lot of cloth so it just looks like a big lump of white. Because I've searched for places that exist on there and I haven't found them. You know, when I was there, I was like, oh yeah, I'll just look for that and look for that and look for that. No, you know, even when I found those places previously and then looked again, they've disappeared or moved. So there's a lot of hidden stuff. The same as with the military bases and anywhere that's covert that they wouldn't want on Google. They'll ensure that it's either edited, deleted, or it's not put in there in the first place.
Yeah, I found a lot of places like that where
Yeah.
they actually there's like 2-3 years of missing aerial topography coverage, where as soon as you zoom in, they shade over the area.
Yeah, it only
You see
allows
it
you
from a
to zoom
distance,
in
but
from
when you
certain.
zoom in, it's not there.
That's right, and they've kind of almost do it so you can zoom in, but as soon as you get close to it, it just breaks up and you can't see the image at all. That's the other way that it's like a kind of layered tile they put over it.
Yeah, yeah, yeah. You're right. You're absolutely right. All right, man. Hank, man, it was definitely good data, bro. Um, we're gonna keep searching. We're gonna keep searching. Johnny, what do you think we're gonna talk about next time?
I think the search is over. I mean, unless they falsify that null, which they'll never do, it's over. We should move on. I don't know, maybe talk about baking cookies or something, because it's over.
Well, when you're baking cookies, you use a flat.
Yeah. Well, here's the interesting thing, the update I want to give for everybody. That video I put out regarding the nano diamonds that was discovered by NASA, and the meteorites, pretty much the ground we're walking on, they're nano diamonds in the ground. Wherever you live, you got a shovel. The claim is, based on the research papers that I shared with people, you could dig up some dirt in your ground, and if you had a background in knowing how to separate the nano diamonds from the rest of the soil, you're walking on a piece of valuable real estate. So it got my mind going in all kinds of directions with regard to why property is valued the way it is. And when I say property, I'm not talking about the house that you built out of damn concrete and wood and whatever else. I'm talking about the land it sits on. It made me think that the land your house sits on, and the reason why you pay taxes on it, even though you built that house with your own hands and you could pick it up and put it on a flatbed and take it somewhere else, the value is based on the soil that's in the ground. It's sitting literally you're sitting on a foundation of nanodiamonds. And that's why property has its value. Can I prove that? Well, all I can do is where I'm at right now, maybe dig up some soil right out here in the yard and contact a few graduate students, PhDs, who've got specialties in nanotechnology and nanomaterial engineering, and say, hey, can you help me develop a device to sift out the nanodiamonds in this soil and see if it can be done? Because they've been doing it probably for hundreds of years, and they know this. And so I'm getting a lot of people sending me emails with links from like NASA and other governments that are talking about this a lot more. I mean, and I'm not saying a lot more since I put out the video, but it's basically been information out there that we've been largely ignoring, didn't know existed, until I actually researched the data and said, whoa, you're telling me the soap, shampoos, toothpaste, the technology in your computer, they're using nano diamonds for computers, they use it for your dental care, polishing your teeth, everything. I mean, we use it for drilling, you name it. So am I going to go digging into that rabbit hole? No, that rabbit hole is really way too deep for me to go into right now by myself. But I want to look into this a little bit more. I need to know what light is being generated to use nanodiamonds as a prism to refract and reflect light onto the Earth. Because I think the moon is doing something, has something to do with it as well. Hell, the moon could actually be one giant rough damn diamond in of itself. It could be. Now I'm starting to focus a little bit more on what the sun really may be. So I'm working to try to get in touch with Eric Dollard again. And if I can get in touch with him, he's going to be the next panel member, hopefully on the next show that we do this weekend. I'm trying to get in touch with him right now because he studied the sun for 4 years. And he could give us some clarity on, some revisited mechanics behind how he thinks the sun is working, what it's doing, where it may be located, what it may be, what it may not be. He's saying the sun is not generating anything. He said it's some sort of transformer from another dimension. He says it's not giving off any sunlight in free space. He goes, there's no light traveling. He goes, that light could be minutes old, seconds old. He says there's no such thing as light years. I mean, if anybody has ever heard the conversation between Eric Dollar and I, it was like 1 hour. It's on my channel. I'm going to try to get in touch with him again, and we'll have him on the panel, and then him and John and Mark and me and Robert. And
hey, Robert, what you just said, I hate to tell you, but it kind of corroborates what the Bible says too.
Yeah, it kind of does. Yeah.
The light came before the sun.
Well, yeah, you're going right there to see. You know what, Judas?
No, we don't have to go there. We don't have to go. I'm just pointing that out. That's all. That the science.
Tell them again, Mark.
Every person I bring on this panel is supposed to be on my side. You guys end up turning over to John. How much is John paying you guys, man?
You want to be the naked emperor, huh?
How much is John paying? Y'all you love having me out in the cold by myself. I got one guy is maybe here for me, but he chewed me out this morning too, putting a sarcastic comment on my channel. Deva, Mr. Claim Your Inheritance, he's got a cool channel too. You guys should take a nice little gander at what he's talking about. It's called Claim Your Inheritance. They go way back to
with an empty mind.
Yeah, with an empty mind. Anybody's welcome to go in and talk on on the conversations they have, but they go really way back. They really study the things that were going on in Egypt. They talk about the original Hebrews, and what they were into and how they were constructing things. There are brief discussions about the original engineers and builders and constructors of, this potential virtual world or world we live in, period. I mean, there's some interesting conversations, and there's
a lot of fire and brimstone too. So if you
I mean, I will tell you, they definitely dip their feet into the science aspect of it, the historical aspect of it, and then the logical aspect of it. So they're combining a whole bunch of things as well. And, it was interesting. I stumbled across this channel one night, and I went in and started listening, and there was some psychotic guy in there who just wanted to label every person who was inside the chat talking being as racist as hell, and I went off on him. But, that's neither here nor there. That guy's not around anymore, but I've known Claim for a while, and we share the same views and ideas. We exchange information, and they see the same things that are happening in what we're talking about. But these guys really stay on point with regard to construct and design of the Earth, how things are working, how they're functioning, and they don't get involved in all of the infighting drama that's occurring in the flat Earth. You'll never see any of the guys on his panel hanging out in some of these other troll and crazy ass flat Earth channels. They stay on point when they come in there. Everybody has something to contribute and share, and they discuss it and analyze it and assess it. And there is no right or wrong. It's just you put it out there, show us what you got. How can you prove this? What other information you have? And yes, John, they are going back to the Bible and the Hebrew section of the Torah, the Quran. They're addressing all of it. So, John, you may find that interesting as well. So, but other than that, Robert Shortman,
thank you,
Mark
Robert.
Bailey, Devad, Mr. Hank Hill, it's been a pleasure, man. It's been a pleasure. I really appreciate, man, you guys coming on board to do this thing. And I'm gonna keep down the path. John and I are always we're gonna keep talking about the physics, the scientific method. I found out that someone who is a well-known theoretical physicist actually may be my instructor next month. So I called his office today at the university and got the voicemail, but I gotta just play it careful with that. But definitely I'm seeing a lot of talk online about the simulated universe, and John and I might talk about that next. Nick Bostrom says some interesting things, and we're going to see if we can break that down, because I'm on board with Nick Bostrom, but he's still undecided. I'm a little bit more, how should I say this? I'm more convinced on one of the three hypotheses he throws out with regard to the universe being simulated.
And then we're going to evaluate whether they're hypotheses, scientific hypotheses, or not.
Yeah, so that's probably what we'll talk about this weekend. I don't know what time we'll do it, but I'm just trying not to telegraph these, because every time I do, we end up having technical problems. But just, you guys will see it when it pops up. And if you got anything else to share, you got my email. Shoot me an email. I am reviewing all of the emails that come to me and all the information and all the links. And I'm working to put this together, so I'll keep putting out the little short videos. And I'm open to any ideas that make logical sense, that support the methods that we are using to prove or disprove, verify, confirm, and qualify every piece of information we're putting out. Okay? So if anyone has any questions, please feel free. Ask now or forever hold your peace, or send me an email privately, talk to me about anything. And if you don't have any questions, like I said, it's not what you know, it's what you can prove. And it's all about setting the truth free from a lifetime of bondage. Let's see. You guys all know who Robert Shortman is. You know his channel. I don't think Mark, you got a channel, Mark?
No, I don't have a channel. I just
Okay, yeah, Mark's just a free floater. He just likes invading other people's privacy.
Yeah. But I'll tell you what I do need. I said it before and I'll say it again. I need 1 or 2 people from the Southern Hemisphere.
Oh yeah. The Southern Hemisphere thing.
I'm telling you guys, this thing will work.
I'll see if I can get in touch with some people. I did when I did the sun up, sun down thing. I did get a few people's contact details, so I'll see if I can get anybody from that, or see if I can get,
what
some
they need
details
is
like
ability, they need ability to get a bearing
and
an angle to the moon.
Okay,
bearing and an angle, so they can get those details.
Yeah, Ben Farrell said, yeah, Ben, I will watch Tom Campbell's videos. I will, on the double slit. I will watch it.
Is I'll find the information, I'll pass it on to Robert, and then he can get it to you, because I haven't got your contacts. So.
Or Robert can give you my info. You can contact me directly.
Yeah, I can do it. Okay. Hey, listen, Dennis, who was it? No, Aaron Mizuto wants to know, he lives in Hawaii, if you need help from him.
Yeah, this is one of the guys I was going to mention.
we'd have to check on a map. That might be too far away, but I can't say for sure. It might help. We'll have to look at it on a map.
All right. Aaron, I got Aaron's number, so I got Aaron's number, so I'll put you in touch with him.
Okay.
But other than that, people, it's been fun. It's been exciting. You know.
Oh, hey, one more thing, Robert. We've got Dr. Zach on board with this too, so he can do the AutoCAD.
Okay, cool. And let me see. Let me put claims. Let me put claims channel link in the chat for everybody else to see. And again, claim is wide open to any ideas, any opinions, any new information towards the same goal that we're all working towards.
Hey, Robert,
Same goal.
I'd like to plug Dr. Zach too. His channel's outstanding.
Oh yeah. I watch him a lot, dude. I watch him a lot, Dr. Zach. It'd be good to have him on too, dude. It was good to be having him on.
Yes.
I have a channel too, but for the most part, I'm inactive. I've been hanging out in the Flat Earth debate room, smashing the globe, just about 24/7. Only taking a break to
I
sleep.
listen to Hank a lot too, man. I like when he's in there.
And
So
hang out at Free Chan too.
The hell, Bobby?
Yeah. So you guys can find Hank on Free Chan. There's a lot of drama in there, so just listener beware. Listener beware. You guys know Robert Shortman's channel. Let me put his channel link in there. You guys know where to find John at. You can always find him on Skype too. You talk to him.
Yeah, that's
If you guys ever see a response in the video chats on the videos from Quantum, was it Quantum Eraser, John?
Yeah, what a surprise, right?
Yeah, Quantum Eraser. You'll know that that's John. So feel free, fire away. I need some new troops, man. I'm getting betrayed left and right. I feel like Julius Caesar.
The Emperor does wear clothes.
Yeah, I feel like Julius Caesar. Hey, tu, Brute.
I'm going to use a Railgun.
All right, guys. It's been fun. Peace out. Take care. It's not what you know, is what you can prove. Be good. And stay in touch. Later.